Good morning, all. Myself, Dr. Vemula Anand Reddy, Assistant Professor at Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the last class, we have seen about the introduction and the syllabus that we are going to cover in engineering geology. As well as we have seen what are the course outcomes, course objectives, and some part of introduction of engineering geology, etc. And later we have seen what are various types of geology, like physical geology, paleontology, etc. So I have also highlighted regarding sedimentary rock, igneous rock, and metamorphic rocks, etc. Now, in today's class, we are going to see what is the importance of engineering geology in terms of civil engineering aspect. As well as with the start of today's class, we will see a few case histories that has led for the failures, drastic failures, I can say, where engineering geology, if engineering geology might have been studied or investigated in an intensive way, then this catastrophic failures may not have been happened, or the loss of human lives may have come down. So the first failure, I can say, that is the most classical example, which is Leaning Tower of Pisa. So I think most of us know this, where it is an inclined building. So the tower is almost tilted to 5.5 degree. So if this is the north side and this is the south side. So on the south side, after the construction, earlier the construction was only up to one level. Later, year on year, the construction has been raised. And during the construction, it was assumed that it has to be in this way. So as the construction has been proceeded, the structure started tilting. The structure gradually started tilting in this fashion towards the south side. So the maximum tilt was up to 5.5 degrees. This total structure was constructed for over 200 years. 200 years this total structure was constructed, and as the construction has been proceeded to the higher levels, the structure gradually started tilting. So till then, none of it is around 1800s, and up to 1990 the construction has been continued, and up overall around 199 to 200 years the complete structure has been constructed. So by the time the total construction has been completed, it has been happened to see that the structure slowly started tilting to one side, and it was creating some panicness in the place. So later the officials have come to know that there is some problem that is creating the tilting. So what was the problem? So the ground level on the south side, the soil was poor soil or an expansive soil. So, and as you see, there was some water drains that was traveling on the north side, and when the rainy season or the winter season comes, the structure was tilting like anything. And again, during the summer and the hot seasons, the structure was stably standing aside at straight. So as the time passes, the structure started tilting and tilting and tilting. So now the geotechnical engineers have not done any sort of engineering geological study, and the study of the investigation that has to be done on the base of the foundation has not been done. So that is the reason where the structure has started tilting on one side. Now the structure has to be it is completely a stone structure, and it is one of the famous Baptist church that is available in Italy, Pisa. So now there is a scientific challenge that has come to engineers. So what they have done is they have added first of all the soil on the north side has gradually started opening. So what they have done, they have dug a very big tunnels on the this side, where and they have diverted also the water level to the other side, such that due to the instability, the structure may withstand. And later what they have done, on the other side of the structure, they have added lot of weights. Usually they are lead weights, which is having high density, so that made the structures to be stable. Later lot of steel ropes and other objects were taken, and they have tried to completely make the structure tilt. But at the end, after continuous 10 to 12 years hard work, they were able to make it straight up to 1.7 degree or so, and the structure is still somewhat tilt, but it is safe and it is open to public in the year 2001. So I have given such a long information. So what was the need? What was the need? Why should one understand these things? So the main reason is the geological perspective was not knowing by most of the foundation engineers. So one side it was completely tilting, and the other side it was at the same position. So it means that the other side there might be some soil like material where it is not able to withstand the loads that are overcoming from the top. Fine. So hence the study of geology has become very vital, and this particular leaning tower of Pisa has become a benchmark for an study in soil mechanics, and it has arisen a lot of knowledge that the importance of studying the subsurface before starting any structure, which is of very importance. Hence, this Leaning Tower of Pisa made a classical example for a person to study the soil investigation before laying any kind of foundation on a larger rates. So now we see some brief discussion on this. So the leaning tower was the leaning was caused by uneven settling of the building foundation in the soft ground. So as I have already highlighted, and it is famous for unintended tilt around 56-meter tower height, and it has took around 200 years to build. So the method known is soil extraction. Soil engineers dig a series of tunnel on north side to remove the small amounts of earth, so the tower leans to the south. With the help of steel cables, they pulled it back to the original position. So the project team also found that the tower tilted more in the winters at the north, and north side was stable with higher than the south when it rained. So this lifted north side even more. So engineers dug drains so that the water could flow away into the wells. So the tower straightened itself by 38 centimeter after the work was done, and continued to straighten, and it is reopened to public in the year 2001, as I have highlighted. Now coming to one more classical example, which is Baldwin Dam, where this dam was constructed to provide water from south to southwest portion of Los Angeles, California. So the Baldwin Dam reached the height of 262 feet and stretched to 650 feet in length. So at 3:38 p.m., in December 1963, the Hills Dam breached, releasing a majority of reservoirs of 250 million gallons of stored water. So the sudden release of huge water resulted in death of 5 people and around 11 million property has been damaged. So here we can see how the entire structure has been collapsed. Here it is clearly seen. So the entire soil has been washed away. So what was the problem? What was the geological phenomenon that has caused and that has led to the failure of this particular dam, and it has continued to take the 5 lives at that particular moment. Next classical example is St. Francis Dam. The St. Francis Dam was completed in 1926 in San Francisco, about 30 miles from 50 kilometers from northwest of Los Angeles. So the dam purpose was to provide a reservoir for Los Angeles. So several cracks and leaks were observed on its abutments, but engineer Moland dismissed that this is normal. After the reservoir was filled with its full capacity for the first time during March 7, 1928, he inspected and the dam is proclaimed as safe. But later, just before midnight on March 12, just see the difference, March 7th and March 12th, however, the massive concrete wall collapsed and sending the billions of water rushing down to canyon towards Pacific Ocean. So the town of Castic Junction, Fillmore, Bachelor, Peru were flooded and more than 1,000 houses were damaged or destroyed. So the official death toll was around 450, but the number killed was likely higher. So an investigation into the disaster concluded that it has been caused primarily due to unsuitability of San Francisco rock for supporting dam and a reservoir. So there was a San Francisco rock supporting at the dam at the reservoir where it was not supporting for stability. Hence, after even after the engineers have checked and they have told it's safe, but once the water level has reached at its full flood level, see the entire flooding has been done and the dam has been failed. So these are the few classical examples, and there are many more. Even in India also there are many more classical examples due to the geological failure or due to the failure due to lack of some imperfections during the construction, or there might be any material, or there might be any physical, there might be any earthquake movements, etc., 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 due to the instability, due to the sudden failure of this material. So the entire dam structure may get failed, and this leads to a huge failure. So now coming to the importance of geological studies in various civil engineering projects. So before constructing roads, bridges, tunnels, tanks, rivers, reservoirs, building, selection of site is important from the point of stability of foundation. So geology provides a systematic knowledge of construction materials and their properties. The knowledge about the nature of rocks in tunneling and construction of roads. The problem related to foundation of dams, bridges, buildings are directly related with geology in the area. So the knowledge of groundwater is necessary in connection with excavation works, water supply, irrigation, many other purposes. So one should always understand that in the city like Hyderabad, most of the time the water pipelines, sometimes it may get repaired, or it may get the new lines may be laid off. So the before laying itself, the team must have the clarity that what kind of soil material is present over the current location, and what are the suitable measures that have to be taken before opening up the line and for a proper construction purpose. So the knowledge of erosion, transportation, deposition by surface water helps the soil conservation and river control. So the importance of geological consideration in various civil engineering projects. Geological maps and sections help considerably in planning many engineering projects. If the geological features like faults, joints, beds, folds are found, they have to be suitably treated. Hence, the stability of the rock and structure is important. So that is what, due to the instability of various rock-like material or the soil-like material, the geological failures is most likely to happen, and it is very important for the duty of a foundation engineer to understand what might be the actual problem, and he has to encounter so that the problem may be solved and there will not be a very drastic failure all of a sudden. So pre geological study of an area concerned reduces cost of planning work. So these are the various importance of geological studies in various civil engineering projects. Now coming to weathering of rocks, the deterioration effects due to weather, climate or atmospheric agencies on rocks may be described as weathering of rocks. So the different kinds of rocks which are formed under different conditions undergo disintegration and decay when exposed to earth's surfaces. So the different kinds of rocks which are formed under different conditions undergo different disintegration and decay when exposed to earth surfaces. What this mean? So the disintegration undergoes at various temperature conditions, say it be, or the rain, or any acid rain effect. So the two important classifications that can be denoted as physical weathering and chemical weathering. So the physical weathering is nothing but mechanical or physical weathering is nothing but which involves the breakdown of rocks. So the soils through which the direct contact with atmospheric conditions with heat, water, rain, ice and pressure etc. creates the pressure, and due to this continuous changes in the atmosphere or on the material or on the rocks due to various agencies like wind, heat, water, ice, so they change their behavior with various agencies. And also the frost action like ice wedging, temperature changes, thermal extraction and compaction etc. And salt weathering, crystallization of salts in the cracks crossing expansion, wetting of drying organisms, root action or action of plants, burrowing animals etc. Means the due to the vegetation, if the roots that are penetrating into the rock, there is a very high possibility of splitting the rock and forming larger sizes of cracks. Hence the cracks may increase day by day as the trees grows inside the rocks. This way vegetation is also part of the physical weathering. So this is the example of physical weathering. The thermal stresses occurring in the desert climate, that is during hot the day and cold during the night. So the heating and cooling processes that happen every day put stresses onto rocks in the outer layer, causing the outer layers of rock to start peeling off as a thin sheets. So like in the day the temperature may be hot, and in the night the temperature may be cool. So due to this continuous freezing and thawing effect, freezing effect in the night and thawing effect in the day, the continuous heating and cooling processes put some stresses onto the rocks, where the outer layer of the rock start peeling off into the thin sheets due to these changes in temperatures. So this is one of the example. Next, coming to the frost action. Frost action, as it is said, if the rocks are filled with water, and due to reduced temperatures, the rock, the water present inside the cracks gets into frost. And this frost, due to increase in the volume, the expansion of the cracks may develop, and again the crack may still develop, and the rock gets splitted. Later, vegetative action, where the rock, where the roots of the plants is completely penetrating into the rocks, and it is splitting into the rocks, and thereby the rocks are getting into they are increasing the cracks on its level. Later, the temperature action, as I have already highlighted in the first slide of physical weathering, the temperature changes altering the hot and cold temperatures weaken the rock as it expands and constructs. So there is no much difference between the physical weathering in this slide and also this slide. Both are one and the same, where we can say it as temperature effects. Later, aberration. So the various agencies like wind, ice, water, and due to gravity, the material may be transported from one place to another. And also the agencies like water, air carries some dust particles, where it is hitting the rock particles while it is moving away. And also the water, when it is traveling from one place to another, due to the continuous movement, it may happen that the abrasive forces which increases the forces, and it may peel off the material little by little, and at the same time the material starts degrading as the time passes on. So this is the action of aberration, where the material starts peeling off, and due to the abrasive effect. Now coming to the chemical weathering. So these are the few important aspects of chemical weathering. Chemical processes alters the nature of the earth material. Solution by acids, atmospheric CO2, hydration and oxidation, salt weathering, wetting and drying, organisms, root of plants, burrowing animals, etc. So the chemical weathering involves the direct effect of atmospheric chemicals or biologically produced chemicals into breakdown of rocks, soils, and minerals. So when the water comes in contact, in the with granite, feldspar crystals into the granite react chemically, forming clay minerals. The clay weakens the rock and making it more likely to break. Example of this of weathering is rust formation with rocks, and with when oxygen reacts with iron Fe, etc. So we know that bauxite is one of the ore. So if there is a presence of any Fe, iron like mineral, and if there is any chemical changes in the atmosphere due to some moisture effect or water, etc., so the rust may change, the material may change into the rust as it starts corroding, and the color of the rocks changes with the presence of iron oxide, and so the weathering becomes more easily to break. So this is a classical example of Fe, or red colored rock. And later it is a chemical oxidation where occurs when oxygen from the air combines with iron rich minerals or rocks, etc. Later, the carbonation occurs when the water combines with carbon dioxide into the air to form carbonic acid, easily, which dissolves rock-like material into limestone and marble, etc. So, coming Okay, so in India, like we can see some places in Vizag where we can see this kind of situations occurring. So these are the events where one can recognize the how the weathered rock look likes. So weathering of rocks usually develop brown, red, and yellow color on the surface. Weathered material usually exhibits change in color intensity and strength. So they lose their natural original shine and fresh appearance, and also they become less transparent or tend to become opaque. So hence in the total class today, we have seen what is the process of physical and chemical weathering, and also the importance of engineering geology in terms of civil engineering perspective, and as well as the what are the basic or the failures that have happened earlier because of some engineering geological studies, or the studies have not done intensively such that the failures might happen. So I have given you the three classical examples of Leaning Tower of Pisa, Baldwin Dam, and also the San Francis Dam. So, we will continue the same or the upcoming topics in the next session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.